When you hold something like this, to some people it just looks like a pile of mud, but I see these seeds and I can see life coming back to the pond, and it's entirely driven by nature. You know, we just expose these seeds and nature does the rest.
So here we've got a really nice example of a pond that we restored in 2015. Really good habitat for frogs, different amphibians, newts species as well. And you can see as well, we've got this lovely grassland has grown up, so all these sort of side margin plants, rushes, we've got dragonflies coming through there, so a real mixture of wildflowers, particularly in the summer.
What are the signs that this is a healthy, restored pond?
So you can see now over the pond, we've got lots of light coming down. We've got different types of plants. So we've got plants that come out of the water, and there are emergent plants or emergent vegetation. They're really good for dragonflies to climb up and then turn into the adults in summer. We've also got weeds under the water, and they provide lots of oxygen that rise and bubble up and provide that oxygen for all the creatures to live there. And then we've got plants that live on the surface as well. So you can see a real mixture of plants living there, but lots of open water as well for the invertebrates and insects to live. And things can get to this water quite easily as well.
This is rural Norfolk. It's tucked into a corner of the UK's eastern coast, known for its natural beauty. It's also home to over 23,000 ponds, more than any other county in England, and one of the highest densities in Europe. But not all ponds here are as lush as this.
So it's the biodiversity around this pond that is the sign that it's a really healthy one.
Yeah, we can see lots of insects coming around. We can see birds in the trees that are coming to visit and eat those insects. We'll see small mammals here. We'll see deer coming in to drink the water and other creatures. So a mix of aquatic wildlife and also some terrestrial wildlife as well coming to visit the pond.
Across the world, wildlife populations have shrunk by an average of 73% in the last 50 years. By restoring ponds, Helen Greaves and her colleagues at the Norfolk Ponds Project hope to bring back some of that lost biodiversity and help mitigate the consequences of climate change. They're collaborating with scientists in the UK and Europe as part of an EU-funded initiative called the Ponderful programme.
What makes ponds an important thing to focus on?
As you know, for us, we need both food and water and oxygen to live, and ponds provide the same things for wildlife in the countryside. And thinking about keeping that water clean, fresh water all year round, and how do we do that in terms of climate change? So as climate change occurs, we might have warmer summers, we might have more drought conditions as we've had before, and that might mean that this water is lost. And particularly where we've got very overgrown ponds, like the ponds that we've been researching, that water is taken up so easily. When we take the trees away from around the edge of the pond, that water, and you can see here, this water level is really high and it stays like that all year. And so that provides a water source and therefore food for all the creatures to come and use it.
What species have you seen restored here?
So just a year or two after restoration, we found the holly-leaved naiad, which is a really rare species for Norfolk, and that was a really exciting find. But it's not just the rare species that's exciting, it's sometimes just the common things and the mixture of common things. So I've spotted some water mint over here, I'm going to get you some. It's a really good smell to it, so. So have a good crunch it up in your hand and then have a good smell.
Oh wow.
It's lovely, isn't it?
Kind of a peppery, minty smell. That's
so
gorgeous.
Plants like this that have leaves and that are around the edge of the pond are really useful for things like newts. So when newts lay their eggs, they fold them up. They lay it in there and fold it up and protects them as they come into their larva form.
So it's not just a plant that smells nice for us, it has a really important role for the wildlife that live here.
Absolutely. So these are really important. The plants under the water provide a home for little insects to hide from and hide away and provide oxygen into the water. So it's about the mixture. We've had over 40 wetland species recorded at this pond here. And so it's about that mixture and the number of different things that you find, not just the rare species.
In fact, ponds support around 2/3 of freshwater species in the UK. They also give those species a valuable lifeline.
As the climate changes, different species might want to move to different areas. So they can use these ponds in the landscape as stepping stones to move into different areas if they need. They can also provide benefits in terms of greenhouse gases. After restoration, what we found is that less carbon dioxide and less methane was being emitted from the ponds. So that's got a dual benefit of it providing a home for wildlife, somewhere that species can move across the landscape, water for wildlife, and also we might be reducing methane and greenhouse gas emissions as well as carbon dioxide. So really interestingly, behind you now, we've got some swallows sweeping low, and because of the low pressure, they're coming down to feed over this area of wildflowers, but we'll often see them sweeping down over the pond, and they're feeding off the emergent insects that come off the pond. And when they're open, oh, we've got a kingfisher just over there. Fantastic, it's just landed.
Oh,
there we go, let's see it across
look
the
at that.
top of the surface.
Bright blue back.
So many birds will come down and sweep over the surface and feed off those insects that come in up from the pond.
I love the way that you really light up when you're talking about that. It's really a real
That's really exciting
moment.
Nice.
The project is the brainchild of Professor Carl Sayer, who leads the Pond Restoration Research Group at University College London.
Carl, hi, nice to meet you. I'm Reya.
Nice to meet you too. Do you want to see some ponds?
Love to, thanks.
He actually grew up in Norfolk and uses some unique terminology to describe the ponds he and his team are bringing back to life.
So I'm going to show you a ghost pond now, and then some of the ponds we're restoring, which we call zombie ponds.
I've heard of duck ponds, I've heard of bathing ponds, but I'm yet to experience a ghost or zombie pond.
Yeah, so a ghost pond is a pond that's been completely filled in. That might have happened 50 years ago, 100 years ago, or many centuries ago, but it's been levelled over to make more farmland. So filled in with soil and bits of hedgerow and tree stumps, and it disappears, but these ponds don't completely disappear. They are prevalent as sort of black marks in the field, bits where the crop grows differently, where the water catches in winter, and sometimes where you get a little bit of a mist in the winter, just hanging over the crop, you know. Sort of mysterious mist gives away the ghost pond. So they've disappeared, but they have some kind of presence in the landscape. So you can nearly always see them.
And this is what we can see here?
Yes, that's a ghost pond, yeah. Can you see the crop is sort of struggling to grow here, and the soil is a bit of a different colour to elsewhere. And also you can see that even though it's been levelled over, we're in a slight depression in the field. So it just feels different. So that was a pond. In fact, it was a pond quite some time ago. It's not even on the earliest maps. So maybe at least before the 1880s, there was a pond here. The key thing we want to get across is that a pond could be here again.
How do you know it was once a body of water?
There's no presence of this pond on old maps, so that doesn't help us. But what we did find while we were searching here is little fragments of aquatic snail in the plough soil. So when they ploughed, they obviously brought up a bit of the old seed bank of the old pond, a bit of the old sediment, and you can see the little bits of snail in the soil. So it's a giveaway of this as a ghost pond, yeah.
Some of these ghost ponds might be truly ancient. Norfolk is also home to many pingos. They're pools formed when ice melted and collapsed at the end of the last ice age. But not all the ponds here were created naturally. Many were dug in for farm animals to drink from. In some parts of the UK, ponds have formed in the craters left by bombs dropped by German warplanes during the Second World War.
What do you do when you find these sites?
We would try and restore it. So I know it looks almost impossible. You think, how can we do anything with this? You know, there's certainly nothing living in it, is there? But we can restore this pretty quickly. So we usually dig a trench right through the middle, and we dig down gradually until we can find the old sediments of the pond, and we nearly always can. And once you find the old sediments, we then stop, and then we dig another trench the other way and find the sediment the other way, and then we just dig a pond to follow that sediment through the field. And the most remarkable thing that I think we'll ever discover is that the seeds of the old pond are alive under this field. And when we restore it, the plants will come back from the past. So they are truly ghostly. They're not completely gone, they're semi-alive, you know, and we can bring them back to life.
Why do you care so much about restoring ponds?
I mean, can you think of anything more important to do, really? You know, freshwater habitats are declining more than any other habitat. The species are in free fall. And this is a quick way of bringing back a really biodiverse freshwater hotspot in the middle of an arable landscape, an agricultural landscape, where we need that water the most. Everyone benefits, but especially the wildlife will just explode here, you know, and it'll be just as quick as when we restore a pond that's existing. It's just as quick because of this magical seed bank effect.
Europe has lost around 50% of its ponds over the last century. In the UK, around 500,000 have disappeared from the landscape. Of those that remain, around 80% are thought to be in poor condition. They're either overgrown or contaminated by runoff.
We're going to take you to an overgrown pond, and this is the kind of ponds that we look at in the farmland.
Ah, so hidden behind the bushes,
Yep.
there is a pond. Oh wow, that's quite a tight entrance. There we go. So is this one of the ponds you're going to be restoring?
Yes, this is our overgrown pond, or our zombie pond as we like to call it, because it's in that kind of half living, half dead state. So there's a few creatures still in the water, but the water level's really low now, and actually it can dry out. And in drought years, it will dry out and there won't be any water in this pond. So, and that's partly because these trees are taking up all that water. So what we're going to do is take away some of the trees there over the top, open it up to the sunlight, dig it out, and then this will become an open pond.
You've brought a net along with you.
So we're just going to have a look at the invertebrates that are in the pond now. So usually there's not much living in this overgrown state, but we always like to check. It's good practice just to check what's there before you do a restoration, so that you don't take any rare species or have any impact. There are some rare species that do use overgrown ponds, but it's not very often that we find them. So if we did, we'd perhaps pick a different pond to restore.
Right, okay, so what you're checking now is that this is the right pond
Absolutely.
to get working on.
Yep. So we just do a little dip with the net, and we do this a few times, and then we can have a look by popping it in the tray here. We can just have a look if we've... And you can keep doing this. It's good to have a good survey of the whole pond.
What does this sample tell you about the health of the pond?
What we're really seeing here is really the leaf litter, and that's the leaves that are falling down from the trees, and that's the reason that we don't really have any life in the ponds. So all that leaf litter falls in and it becomes anaerobic, or there's no oxygen because things are all breaking down all the time, and then things can't live where there's not very much oxygen in the water.
What can you see in there insect-wise? Because I can see a fair bit of movement.
Yes, definitely. So as the water settles out, oh wow, we've got a lovely beetle here, a large beetle.
It's like making a beeline for anywhere with shade.
Yep. And these are the kind of things that we would check that this is not a rare species. There's many, many different water beetle species in the UK. This one is quite a common one, so that's okay. And these can fly around like ladybirds. They've got wings and they can fly around from pond to pond. And then the other thing that we've got a lot of is the red things are chironomids, or non-biting midge larvae. So lots of the kind of insects and flies can tolerate these low oxygenated waters. So the other thing that this pond net's really useful for is to use it to see how deep the leaf litter is. So over the top of the pond, we've got a lot of shade from all the trees, and all those trees are putting in leaves all the time. Year on year, they put in leaves to the pond, and this builds up over time and creates this anoxic conditions. It means that there's no oxygen, and it's really difficult for species to tolerate and live in those anoxic conditions. So we can push this in and see how far it goes, and
Oh wow.
we can see that this is really quite thick. It feels firm underfoot, so it's not too bad to go in with, but it means that the digger has got a lot of leaves to take away and dig out. So what we're trying to get back to, therefore, is this really firm base. So the digger's going to come in and just take all this organic matter, all the leaf litter, all the sticks that have built up over time, and put that over onto the field. And then we'll get back to this firm base, which is a clay-like base, and that will allow the seeds to bury in, the root in, and then start growing, because then they'll have light as well.
So this is a reset almost of the pond.
Yes, exactly. That's what restoration is. So we take it back to an earlier stage, we reset it back to how it was perhaps 100 years ago.
Volunteers at the Norfolk Ponds Project are restoring this zombie pond back to life, using a range of tools right down to their bare hands.
Right, where can I lend a hand?
I'll give you some things.
I get stuck in with the high vis, thank you.
Safety goggles.
Thank you very much. Gloves, lovely.
So the key elements in terms of the science behind this is letting light back into the pond, so that allows photosynthesis when the plants can live there. But for the plants to live there, the aquatic plants, we need to create water again. So we're going to dig out, scrape out all that organic matter, and that'll leave a firm base for the seeds that should already still be there, these historical seed bank, to reroot and then start growing again. So we're creating light, we're creating air, so the water circulates, and then that creates a great habitat for the plant to grow, and those plants provide that home for the invertebrates and creatures. And then the terrestrial animals can also come along, they can drink water from here, so the water will remain here all year round now.
I feel bad seeing all your team working hard. Let me go and get stuck in.
Let's go.
Yeah, I have that. Sorry, that was not much help. It really is just crazy to think, just an hour or two ago, we were standing in this exact spot and it was pretty much entirely shaded, pretty dark and covered. And now, with the work of the volunteers underway, it's totally opened up and light is pouring in on this pond. It looks like a completely different piece of land. So what stage are you at in the process now?
Well, making the first steps, but we've opened up the light considerably to the pond. So yeah, we've just taken over this opened up this side, and then that'll allow both access for the volunteers to get in and out safely, particularly behind us. It's nice and shallow bank, and the digger can come in here as well. But we've still got quite a lot of work to do.
Okay, even so, in just a really short space of time, I mean, 90 minutes ago, we were standing pretty much in this exact spot and it was shaded and totally covered. And now here we are, a bit of work later, totally opened up.
Yeah, so the light's already coming in, and it's also allowing air to circulate into the pond. Before, it was really enclosed. That's a perfect conditions for things like mosquitoes to live and the flies, because they can emerge and they're nice and sheltered. They can still do that now, but now we've opened it up and there'll be many more species that will prefer this open and light habitat.
And, as Greaves has already said, It could help create a constellation of ponds across the region, which different species could escape to under extreme temperatures brought about by climate change. Even the wood that's been cut off is put to good use. Some of these branches will be left in piles next to the pond to become habitats for insects, birds, mammals and amphibians.
So we've come over to this side of the pond, and although we're taking lots of willows down, we're going to leave this kind of habitat. We're trying not to touch this. This is sort of like ancient woodland flora. And so we'll try and leave this. And what's really nice is when you open up the light to this on the banks and around this, all this will come back to life as well. So we're not only sort of looking at the aquatic habitat, but we'll also open this up and we'll get a lot more flowering plants next year.
So there's clearly a lot of thought going into what you do and don't remove here.
Absolutely. So, you know, we'll try and take down the willow, which will come back itself. It'll always reshoot, so we shouldn't be too worried. Wherever we leave a stump of willow, it'll reshoot, and that's a really nice habitat for bees at the start of the year to come and feed from, and different insects. But there's certain areas that we won't touch, and the digger will be very careful about this. And we'll also not change the shape of the pond too much. So we're kind of trying to celebrate how it was originally dug out, and this may have been dug out by hand originally. And so we'll try and maintain that shape and maintain all these different habitats within it, and just kind of try and improve it all.
Yeah, what does this mean for greenhouse gases?
So in terms of the greenhouse gases, the studies that we've done so far, and it's only like an initial study, but we looked at 10 overgrown ponds like this, and we compared them to 10 open ponds, so the ponds that were functioning, and how this will function after it's been restored. And what we found was that in this type of pond, there is many more emissions of carbon dioxide and methane than there is in the open ponds. And that's partly because of that kind of anaerobic conditions. We've got the bacteria that are breaking down all the leaf litter that falls into the pond, and that biological process then produces carbon dioxide and methane. But when we open up the pond, then we get plants growing there, and the same as plants on land. We get that photosynthesis, that gives off oxygen, and so we get those different processes in the pond.
So actually a living, healthy pond does a better job.
It reduces the amount of carbon dioxide and methane that's being produced. So when we think about the ponds in the landscape, most of our ponds in this landscape are overgrown like this. So if we think about multiplying the effect up over that number, you've got many ponds that will be emitting higher amounts of carbon dioxide and methane, but if we open them up and we reduce again that carbon dioxide and methane, but at the same time we improve biodiversity, we're doing two good things at the same time.
Ponds play a complicated role when it comes to greenhouse gas emissions. Studies in the UK have found they can absorb more carbon than woodland. But research by Cornell University in the US says they can also be net emitters of CO2 when the plants inside them decompose. Ponds can also release methane, which is 28 times more potent than carbon dioxide when it comes to trapping heat in the atmosphere. This happens when anaerobic microbes break down, decomposing organic matter on the pond floor where oxygen is low. But the methane emission rates from ponds is highly variable, and a lot more research is needed. Over at another zombie pond, Professor Sayer has deployed another digger to clear out the area.
Nature needs disturbance. Wetlands love disturbance. They need it every so often. So you'd imagine our natural landscapes, our natural wild wetlands, would have been disturbed by river floods, by beavers, by large herbivores, crashing around, gnawing, eating, felling trees. So what we're doing is effectively mimicking that in a farmed landscape, but we're doing what these wetlands need. They require disturbance every so often to open up the canopy.
Restoring the pond floor can also throw up surprises from the area's biological past.
The diggers already made light work of clearing those trees, but they're still continuing. What's the plan now?
Yeah, see, all the tree roots have all come out, He's now getting at the sort of the organic sediment. And what we want to get out is all that leafy, anoxic, black mud that needs to come out of the pond. Once he's done that, you know, we're hoping to expose it. You can just see it over there now where it's a little bit browner, this beautiful seed bank layer, and that would be laid down centuries ago. And it will contain the seeds you know, that were in an old landscape. And there might be 10s to 20s of all sorts of wetland plants, all with long-lived seeds that will be exposed when we dig and sort of, you know, lift the dark stuff from above it. And that's the time capsule, really. That's the life of the pond, because from that, seeds will grow and fill up the pond with vegetation. And often all sorts of rare species will, you know, come to the fore when we do that.
And these are species which, despite having been buried under these ponds in some cases for hundreds of years, are still able to grow.
Yeah, we don't exactly know how it happens. You know, the plants have got this strategy, clearly, that they want to survive long term. They're waiting for a disturbance, you know. And here we're giving them the disturbance. This pond's been waiting centuries, and those plant seeds will grow. And we find that things will come back. We had a plant that came back a couple of years ago, which hadn't been seen in this county of Norfolk for 100 years, you know, so threatened, extremely rare things will come back into the landscape and live in these ponds, and that's the thing that really inspires me, really. It's just brilliant. Oh, you see all that leafy stuff?
Yeah,
that's
and
what we want out.
That's the stuff that
We want that out, yeah.
you can
And
see
the
the
brown
difference
stuff at
in
the bottom
colour.
there, you see that stuff? That might be the good stuff. I haven't had a chance to look yet. Should we go and have a look?
Yeah, let's go have a look.
Okay.
What is it that you're looking for?
You're looking for this lighter coloured sediment, you know. Yeah, that's more like it. There we go, look, this is the sort of stuff, really.
What have you found there?
Well, first of all, I can see the beautiful wing of a fossil beetle, but these aren't fossils. These are beautifully preserved living plant seeds. This is the broadleaf pondweed, yeah. And it's perfectly preserved, look at that. So it's broadleaf pondweed, there's multiple seeds there, and I can also see here, this is the burreed, is Sparganium. It's a big seed. Look, again, it looks good, doesn't it?
That's incredible. It's
Yeah.
perfectly intact. Do you have any way of knowing actually how old they are?
Couldn't tell you, other than I suspect it'll almost certainly be centuries. Don't really know, but I would guess multiple hundreds of years, you know.
And you'd imagine if you're digging things up that are hundreds of years old,
Yeah.
that they'll be, well, long dead. Are these?
I don't think they are, no. I think they look in good condition to me. What we've found is we've actually taken mud from ponds, you know, that we know the mud is, you know, 150, 200 years old, and able to grow that in tanks. So we can grow these seeds in tanks in a greenhouse, you know. So we know we can do this, and we know that a high proportion of these seeds are alive. What we don't know is just how far you can go back through time, you know.
So this is a time capsule of ancient seeds.
Yes,
that you
yeah.
could still grow living plants from today.
Yeah, it's going to be brilliant, basically.
Once you
It's gonna be
start
fantastic.
really inspecting this, you can see
Yeah, look,
so
there's
many...
more there. You're getting your eye in, yeah. That's more Sparganium there, I think.
You're clearly really excited by
Yeah.
this, but why does it matter? What does it tell us?
It matters so much because I think this is hope, isn't it? This is the way we can restore things. This is ecological restoration. We're desperate to undo the past, aren't we? We've made a bit too much progress. You know, nature hasn't done well on that. So we need to restore things, and the best way to do that is to let nature restore things. When you hold something like this, to some people it just looks like a pile of mud, but I see these seeds and I can see life coming back to the pond, and it's entirely driven by nature. You know, we just expose these seeds and nature does the rest.